Welcome to solverfy.
The first part of this question requires us to figure out what the equilibrium constant is for the reaction given, this right here being the reaction given. To do that, we need to know what the equilibrium expressions are for KSP of silver bromide and KF of sodium thiosulfate. We can write the KSP knowing that the KSP expression is always the solid breaking apart into its ions. Then, for the formation of silver thiocyanate complex, it'll be the silver acquiring two thiosulfates going to the silver thiosulfate complex, and it having its own KF value. You'll notice that when we sum these two reactions together, the silver species is canceled, and when it is canceled, summing them together gives us this overall expression. This overall expression then has its own equilibrium constant that, when you add two reactions together, you multiply their K values. So multiplying these two K values together gives us the K value for the silver bromide solid reacting with thiosulfate, and that product ends up being 25.4. So this is the K value for this particular reaction. To know the molar solubility of the silver bromide in a solution that contains thiosulfate, we need to know what concentrations are equal to molar solubility. Molar solubility describes the moles of silver bromide that dissolve in a liter. If 1 mole of silver bromide dissolves in a liter, because the stoichiometry is 1:1, we will get 1 mole of silver thiosulfate and 1 mole of bromide. So it turns out that the bromide concentration and the silver thiosulfate concentrations are both equal to molar solubility. The KSP expression for this K value, well, not the KSP, but the K expression that has this value comes from this equation, and it is then going to be the concentration of silver thiosulfate multiplied by the bromide concentration, both of these are equal to molar solubility, divided by the thiosulfate concentration squared. So we will end up with S squared up top, and because the thiosulfate concentration is given to us at 0.1 molar, then thiosulfate concentration will be 0.1 molar down here, but because of the coefficient 2 up here, we need to square the thiosulfate concentration down here. Rearranging it, we can then solve for S, and in doing so, we get S, a molar solubility of 0.5 molar.